Being a woman in bioinformatics does mean that you need to get a little bit used to sometimes being the only woman in a meeting or in the room or in the class. I think this can be a lot of fun because it can help to challenge stereotypes, but it's also a reminder that we do need to try and get more women into bioinformatics. There's sometimes a stereotype that those who can program and those who are in bioinformatics are men, but of course there's many accomplished women, not only in the history of the field, but that are doing amazing bioinformatics today. I do think representation is important. It can be tough to be the only woman in a class. You can feel like if you don't do well, that you're letting all women down. But if there are women that teach these classes, if there are women that can help TA and other women on the courses, then this can be a big help in reassuring women that are coming into the field that this is a place that they're meant to be. And they can see examples of how women can contribute to the field and the amazing work that they can do. So I'm hopeful that as more women like myself get into bioinformatics, it will encourage young women to consider this as a field. Pathoplexis is really a great example of a bioinformatics platform. It's kind of bioinformatics from top to bottom. This means it's a marriage of technology and software that accomplishes course-specific tasks, but also of thinking about what that means biologically. So for example, in Pathoplexis, we have to take in sequences, decide what virus they are, and then align them to reference sequences and display this information to the user in a way that's helpful and interpretable. So not only do we need to do the traditional work of creating an interface and making pipelines that work together, but we need to know the biology behind what sequences mean and what mutations in sequences mean, so that we know what users want out of that information and how to provide that in a way that's useful for the tasks that we know they'll want to do. Pathoplexis has a lot of different steps like this. And one of the main challenges that we're trying to overcome is to make running those steps and sharing sequences much easier. So we've provided drag and drop interfaces as well as APIs to allow users to upload sequences and share them and get information about them much more easily than existing platforms. On top of that, we think it's really important that scientists feel like they can share their data. And so we allow scientists to have their data as restricted use data, meaning it's protected from publication by others for up to 1 year. This means they can safely share their data for public health use while still knowing that they can publish on it for up to a year and get that important first credit. And again, this is a wonderful example of understanding both the academic and scientific side of the field, where papers and publication are a critical currency in science, but then also understanding the public health side, where it's important that sequences are shared equally and openly and quickly, and then marrying all of that with technology that can help to accomplish that goal. So working on Pathoplexis has been, for me, an excellent experience of showing how wide-ranging bioinformatics can be and how much it can help change a field.